Hello everyone. Today I'll give you a presentation about Onestor hard disk cache setting detailed explanation. We know that Onestor, as a distributed storage software product, can be deployed on a standard x86 server. However, Onestor still has some requirements for hardware settings, especially hard disks that are closely related to storage. Today, we will learn about the settings requirements and setting methods of hard disk cache. First of all, let's learn what is a hard disk cache. The cache is usually a volatile storage medium. The so-called volatile means that the data inside cannot be saved and will be lost after a power failure. The main function of the cache is to improve the system performance between two devices with different rates. For example, usually the CPU processing rate is faster than the memory access rate. Therefore, there is a cache between the CPU and the memory. The CPU will store the data in the cache first, without waiting for the memory read and write to complete, which speeds up the CPU and the rate of interaction between memories. In the same way, there is a cache between the memory and the hard disk. When the data in the memory needs to be written to the hard disk, the cache can be written first without waiting for the hard disk to write to the next operation, thus speeding up the system run. Knowing the role of cache, let's take a look at the main types of hard disk cache. The hard disk cache we often see is divided into two types. One is the cache on the physical hard disk. This cache is located on the hard disk circuit board and has no battery protection. Therefore, when the power supply of the server is interrupted, the data in the physical hard disk cache will be lost. In order to ensure data security, the physical hard disk cache usually needs to be closed. Another type of hard disk cache is the read-write cache of the logical array. This kind of cache is actually a cache module on the array card, and the battery or supercapacitor is usually configured to protect the cache. In this way, even if the server is powered off, the battery power supply can ensure that the data in the cache will not be lost for a period of time. Therefore, we usually enable the read and write cache of the logical array to improve the performance of hard disk read and write. For different types of hard disk, the cache settings are also different. According to the type of hard disk media, we can divide hard disks into two types. One is a mechanical hard disk HDD, and the other is solid-state hard disk SSD. Among them, the mechanical hard disk is composed of magnetic disk and a mechanical head, and it is addressed by the rotation of the disk. For random small I/O read and write, because the read and write areas are scattered, the addressing time is long and the performance is poor. After the logical array cache is turned on, it can greatly make up for the lack of mechanical hard disk in random small I/O read and write. The storage medium of the solid-state hard disk is flash memory particles, and the performance of random small I/O is far better than that of the mechanical hard disk through electrical signal addressing. Therefore, for SSD, turning the logical array cache has little effect, but it will lengthen the I/O path and may even reduce the read and write performance. So, for different types of hard disk, how should the caching strategy be set? After understanding the cache setting strategies of different types of hard disks, let's learn how to set the hard disk cache. Different types of servers and different types of array cards have different methods for setting the cache. Here, we can take the LSI 9361 array card as example. The array card cache can be entered into the BIOS settings after restarting, or can be set with commands under the operating system. The command setting doesn't need to restart the server, will not affect the business, and it's easier when the number of hard disks is large. Therefore, we recommended using command settings on the system. This video also uses this as an example to explain. If you want to set it under the BIOS, the specific operation method can refer to the user manual of the corresponding model server. For Onestor products, after the operating system is installed, the management tool Mega CLI for LSI array cards will be installed by default. With this tool, you can easily query or set parameters related to array cards and hard disks. First, execute the command Mega CLI ldinfo ll a0 to query the current hard disk cache status. This command will display the detailed information of all logical arrays under the array card with the slot number 0. If there are multiple array cards on the server, or the array card slot number is not 0, you need to modify A0 to the corresponding slot number. After the command is executed, in the output result, the main focus is on the keyword cache policy. Among them, the default cache policy is the set cache mode of the array card, and the current cache policy is the current cache mode of the array card. Usually, the display of these two fields should be the same. This cache policy represents the physical hard disk cache. For HDD, the cache mode of the array card should be read back, which means that the read cache is on, and read ahead, which means that the read cache is on. In addition, there is another parameter, no read cache effect BBU, which is the power down protection mode of the array card. When the power down protection mode is turned on, if the battery of the array card fails, the array card will be automatically the read cache is turned off, so that even if the battery of the array card fails, the data will not be lost. The physical cache mode, disk cache policy of the HDD should be set to the disabled. For SSD, the cache mode of the array card should be read through, which means that the read cache is off, and read ahead now, which means that the read cache is off. The physical cache mode of SSD should also be turned off. But in fact, most SSD do not have physical cache, so it can be set to be turned off. In this case, the disk cache policy remains the disk's default state. Next, let's learn how to set the hard disk cache on the command through the Mega CLI tool. We can turn off the physical cache of the hard disk through this command. The X in LX represents the number of the logical array, and the N in AN represents the slot number of the array card, which needs to be modified according to the actual situation. For HDD or SSD, the commands are consistent, but it should be noted that when setting the physical cache of the SSD, because SSD do not have physical cache, the command may prompt that the setting is not allowed. If this happens, there is no need to set up the physical cache of the SSD. When setting the array card cache of the hard disk, for the HDD, the array card write cache needs to be turned on and set to the power down protection mode, and the read cache of the array card also needs to be turned on. Execute the command set on the left. For SSD, it's necessary to turn off the write cache of the array card and also turn off the read cache of the array card. Execute the command set on the right. Through the previous lecture, the introduction of Onestor hard disk cache mode setting is complete. Let's review the main points of today. Number 1. Hard disk cache is divided into physical cache and array card cache. The physical cache needs to be closed under any circumstances. Number 2. For HDD, it's recommended to enable the read and write cache of the array card. For SSD, it's recommended to disable the read and write cache of the array card. Number 3. If the write cache of the array card is enabled, the array card cache must be configured in power down protection mode. That's the end of today's lecture. Thank you.